Hello guys, and welcome back to this channel. Today we're going to be doing this Leetcode problem called the lowest common ancestor of the deepest leaves. Now this is a very interesting question, and I had fun solving it, so we're going to do it together. So it says, given the root of a binary tree, return the lowest common ancestor of its deepest leaves. And then you're given some recall information here that can help you to understand the question further. So it says the node of a binary tree is a leaf if and only if it has no children. And also the depth of the root of the tree is 0. If the depth of a node is d, the depth of each of its children is d plus 1. And then you're also told that the lowest common ancestor of a set S of nodes is the node A with the largest depth, such that every node in S is in the subtree with root A. So that's like really important information. Like if you did not understand it, pause the video and reread it again so that you can, understand what it means. And you're also given an example here. And just by looking at this, you need to remember that we're trying to find the lowest common ancestor of the deepest leaves. So which ones are the deepest leaves in this tree? Obviously it's 7 and 4 because they are the ones with a depth of, since the root is a depth of 0, the nodes at this level, which is 5 and 1 at the second level, have a depth of 1. And then these nodes here have a depth of 2, and then these ones here have a depth of 3. So if you look at this question closely, you realize that the lowest common ancestor of the deepest node is going to occur when the right subtree and the left subtree have equal heights. So in this case here, suppose that 7 did not exist and 2 had only one child, which is 4. Our answer would have to be 4 because that would be the lowest common ancestor of the deepest leaves. So that's how you solve this question. So we're just going to put that into code. So we need to make a helper function called height, which gives us the height of a node. So it returns an integer. So int height takes in a node, tree node root, and then if the root is equal to now, so this is a recursive function, returns 0. And then otherwise return 1 plus max between the height of the left child and height of the right child. This. Then now what you want to do is check if the root is equal to now. So that's a base case. If the root is nothing, just return it. And now you're going to find the heights of the left and the right subtrees. So find the height of the left and right subtrees. So let's call this one left is equal to the height of root left, and let's call the other one right is equal to the height of root right. Now if left is equal to right, that means that you basically have a common ancestor of the deepest nodes, so you return that current node. So you return root. Then else if root is greater, right is greater than left, that means that your answer actually resides on the right subtree. So you need to explore that one further using recursion. So you're going to call the same function, the main function. You're going to say return, then you paste this, then you call this function on the right subtree, right? And then else if that's not the case, then you're basically going to be exploring the left subtree. So you can just say return the same function on the left subtree, this. Right, so that's basically how you solve this question. Like when you arrive at a node whose left subtree is equal to the right subtree, like in heights, then that's the common ancestor. If it's not, you go where the height is bigger, because that basically means that is where the deepest node resides. And then you could potentially arrive at a node, for instance, in the case where we're talking about where, in this case, if 2 had one child, which is 4, you couldn't possibly return 2 as the lowest common ancestor of the deepest nodes, because the left subtree would basically be less than the right subtree. So 4 would be the answer, because its left side would be 0 and the right side would be 0. And let's run code for the base case to see if we have any errors to solve. Okay, so it passes this case, and then now we're going to submit for all the cases and see if it passes. Right, so yeah, it passes. So this is how you solve the problem, lowest common ancestor of the deepest leaves. If you have any questions, or comments about this solution, please post in the comments and I'll be happy to reply. So thank you and see you in the next video. Remember to like and subscribe.